It has been one of those extremely hot days this summer, and we were sitting and sweating in our office, and we were about to launch a mobile-only study with 16 questions, and 8 of them, 50%, were open-ended questions. So my colleagues who were sweating next to me said, "This will never work. You will really experience large survey fatigue." So that's why we added another question. Do you enjoy the study? What do you think? How many percent enjoyed the study? 20, 50, or 80? Who thinks 20? Please raise hands. Yeah, some. Yeah, some. Who thinks 50? Some. And who thinks 80? So, also, there's 50-50 in that. Actually, 90% enjoyed or very much enjoyed taking part. Imagine you could make full use of open text response data at a quantitative, scalable way. Imagine we could get rid of lengthy, cumbersome questionnaires, and instead, imagine we can just ask 2 questions. How likely are you to recommend, and why? Like a Google self-driving car, AI is nothing overly complex anymore. Instead, it enables simplicity and scalability. And Dennis Brosman is leading customer experience insights at Sonos, and he will show us today how Sonos leverages AI to simplify, to speed up, to save cost, but most importantly, to gain deeper insights. Dennis? So that's why we ask ourselves, couldn't it be possible to not just track NPS and its trend, but also get a system which explains us why the NPS increased or decreased, and which are the core key success drivers in a very simple way? So the approach we approach the issue is basically just taking 2 information sources, the NPS question and the open text response to the question, why did you rate that way? The challenge here is how can we explain the outcome with this information? The way forward to do that is basically to categorize that. And categorizing it with thousands of responses all over the world is very time-consuming and also some failure happening. So that's why we are using natural language processing AI that not only helps to speed up, but also helps in doing more consistent coding. Once we have those codes, we can use causal machine learning to understand which of those categories really drive a loyalty. So I will quickly explain both AI boxes. First, there is natural language processing AI. They are unsupervised learning approaches, which are most used, but we leveraged for a reason supervised approaches. Supervised approach means we teach the system to code. So there are some 100 codes from manual coders who teaches the machine how to best code, how to understand sarcasm, and so forth. And the machine needs some pre-processing, which is basically kind of a word model. It is a model which has the relation that man and woman is someone related, or that chicken and chickens are something from very different categories, food and animals. So based on this word model and the linguistic deconstruction, artificial intelligence, a neural network, can then predict those codes. Let's look at the second box. The second box is causal machine learning. So basically what it does, it builds out of the data, out of the codes and sentiment, and likely to recommend how is the causal network, direct and indirect effects. Yeah? So basically it quantifies the arrows here. I'd like to illustrate to you how this works in very simple terms. What you see here is 2-dimensional space. This is sound quality, and this is sentiment, okay? And I have the data here. This is a guy who don't like the sound quality and has low sentiment. This is a guy who already has a better opinion, and he really loves the sound quality. So actually what you see is high sound quality, high likelihood to recommend, high sentiment, high likelihood to recommend. So both correlates, but is it all important? We can use the most simple form of key driver analysis, which is this. It has three parameters. The constant, the importance of sound, and the importance of sentiment. And the key driver analysis only basically adjusts the parameters so it can best predict the data. What you see here is the steepness of sound quality is 0, so there is no direct effect. This is conventional statistics, how you understand the direct effects, not the total effects, because in this example it has an indirect effect. And now it happens, although, that reality is a little bit more complicated. Because it assumes linearities of driver, the more the better, and independence. The parameters are independent from each other. So the reality looks like that somehow there is a guy who is really an absolute enthusiast of you. And this is not able to predict anymore the data, right? If it becomes more complicated. And this is where artificial intelligence or machine learning, or let's call it universal regression. It is a flexible approach which adapts to data and is optimally equipped to predict what your consumers will do. So, and with this approach, we can much more reliable estimate the causal paths here. So this is basically the conventional approach, often too simplistic, and instead artificial intelligence, machine learning is a flexible approach which basically finds nonlinearities and interactions which are unknown upfront. So overall, we prevent spurious correlations, we can self-learn nonlinearities and interactions, and consider indirect effects. But let's look what the machine learning, you may think, okay, that's very interesting. However, how do you know it's the truth, it's valid, what you found? So we looked into the data. Can we predict the outcome in a cross-validated way? And we see that the machine learning explains by 40% better compared to conventional statistics why customers buy. On top of that, it understands the indirect effects of things, because key driver analysis typically don't do that. So overall, we explain by factor 2 better why customers are loyal and others don't. The other question you might have is the manual coding. Can a machine really code like a human? And that's why we tested lots of software systems. And we started with unsupervised software. You all know that there's a Google NLP system, there is Lexalytics, Remesh, Odin-Text, and so forth. They are all unsupervised. And what we learned is this is not enough to predict loyalty and to be as good as humans. That's why we programmed our own supervised system using open source packages, and we were better, but even not good enough, because manual coders achieve 0.7 explanation power. But luckily we found a platform which were really, in this case, even better than human codes, because the machine can better predict the sentiment than a human coder. So I have tons of other examples which we can go later in the discussion, which all show that typically the most mentioned reasons are not the key drivers. So typically looking at frequencies fool you. We see it in insurance, we see it when we do it for brand consideration, and we see it when we look at the drivers of enjoyment for a study. So let's use the time and conclude. What's your recommendations, Dennis?
So my recommendations are simple from the side of the brand, right? As mentioned, we like to understand what drives NPS. It's very important to us. We use this information throughout the company to help understand what we should be focusing on. And so any way we can do this faster, simpler is great. So my recommendations are basic. The first is that this approach, the two-question approach, is simpler. Right? It's much smaller in terms of processing power and the time you need to do it. The second is it's insightful. So what Dr. Frank just mentioned here, like the outcome of the test and what we saw here was on par to what we'd expect with our previous model. And the third is it's affordable, not just cost basis, but also, more importantly, in my aspect, time, efficiency, and your own sanity, really. So all three of these things, I would personally recommend that companies out there try it. It's not that difficult. It sounds complex, but we've shown here it's not.
So